morning everyone. Today we are going to see the topic on minterms and max terms as well as standard forms and canonical forms of SOP and POS, that is sum of product and product of sum. I am Mrs. K. Vanitha, assistant professor working in the department of ECA. So representation of Boolean expressions. The relationship between Boolean variables and output variables is otherwise called as Boolean expression. Boolean expressions are represented by two forms, sum of product and product of sum. Sum of product can be represented by SOP, where the product terms, that is AND terms, are odd together, where in each term will be having a variables and its complemented form. So say for an example, by taking this truth table, we will be having two variables A and B. Each will have a combination of 0, 0, 0, 1, 1, 0 and 1, 1, and this is the output function. And to write the sum of product form, we take 1 in the output, that is the input variable for which the output is 1. This will be, each product term will be grouped together, and the product term for this one can be taken from A and B. A is equal to 0 and B is equal to 1. It can be written as A dash B, and that is 0 will be written by A dash and 1 of B will be written by B. Similarly for the other terms, so that we will be having the different product terms A dash B, A B dash and A B, and these product terms are grouped together to give the function F, that is A dash B plus AB plus AB dash. This is the SOP form. Similarly the product of sum form, and where we are grouping the odd terms or AND together, that is multiplied together. We are taking a group of odd terms and these are multiplied together, and these forms will be generated from the truth table, where we are taking the input variables for which the output is 0 for the product of sum, that is 0. Then the first row it is having 0, and third row and fourth row. Here each sum term will be written by taking the variables A and B, the values of the variables A and B. So if it is 0, 0, it can be written by A plus B. If it is 1, 0, it is written by A dash, that is this one can be written by A dash, and the B value will be 0, so it is written as such, so A dash plus B. Similarly this A, B will be, is having the value as 1, 1, so it can be written by A dash and B dash. So these odd terms are grouped together or multiplied together, then it is called the product of sum form. Then what is minterms and max terms? So this product term is otherwise called as the minterm. So minterm is a product term in which all variables appear exactly once. That is, A will be appeared only once. If we have two variables A and B, A will be appeared only once and B will be appeared only once in a product term, either true or a complemented form. So number of minterms for the n input variables will be 2 power n minterms. Say for an example, this is the truth table, and the Boolean expression for this truth table can be written by the minterms. If a Boolean variable, Boolean function, that is for F for variables A, B and C, will have 1 for the minterms, the function output 1 for the minterms 1, 4 and 6, that is 1, 4, 1, 4 and 6. If we have 1 output 1 for the minterms 1, 4 and 6, it can be written by the Boolean expression F of A, B, C, summation of minterm 1, 4, 6. It can be expanded with the variables. It is 1 can be written by, since we have output 1 for minterm M1, that is 1 is this 0, 0, 1. So A can be written by A dash, B can be written by B dash and C can be written by 1. So for M1 it is A dash, B dash, C. Similarly for M4 will be 100, that is A, B dash, C dash, and M6 will be 110, so A, B and C bar. So these product terms or AND terms are grouped together by means of OR function, so that it is called as sum of product. That can be written by some expression or Boolean expression sum of product form. In notation it is written by summation of minterms 1, 4, 6. Similarly for the max terms are the odd terms in which all variables appear exactly once, either in a group or complemented form. And the output function, here we are taking the output function 0 in the truth table for all the input variables. If we have number of variables n, then the number of max terms will be 2 power n. Say for an example, this is the truth table, and the sum of that is product of max terms will be written by the notation pi capital M for the minterms M2, M3 and M4. If we have the output as 0 for M2, M3 and M5, that is M2 in the sense 0, 1, 0, and M3 in the sense 0, 1, 0, and M5 in the sense 1, 0, 1. If we have output 0 for these max terms, it can be written by the notation as sum of max term as, that is pi capital M max term 2, 4, 5. It can be expanded with the Boolean expression. 2 will be written by 0, 1, 0. Wherever we have 0, give the variable as such. Wherever we have 1, give the complement of the variable b. The 0, 1, 0 will be A, B dash, C. So A, B dash, A plus B dash plus C. Similarly, the other output functions will be written. So standard SOP and canonical SOP. In digital electronics, SOP expressions are used to represent Boolean functions. There are two types, standard SOP as well as canonical SOP. The standard SOP or unstandard, also called unstandard SOP, and the canonical SOP can be called as minterm SOP. Standard SOP is sum of products. That is, standard SOP is a Boolean expression written as OR of AND terms, that is sum of product terms. Each product term may not include all input variables, called as standard SOP. Say for example, if this is the sum of product form, can be represented by Boolean expression A dash B plus BC. This is standard SOP, and we'll have the product terms A dash B and B and BC. Each term does not have all the input variables. Here we see that in the overall we'll be having 3 variables, that is A, B and C. So each term does not contain all the variables. Each product term does not contain all the variables. Here we missed the term C. Here we missed term A. This is called a standard SOP. And the canonical SOP in the sense, here it includes all the variables in every product term. So each product term is a min term representing a row in the truth table where the output is 1. We are grouping all the minterms where for all the minterms having the output 1 in truth table. Let us have the function if this is sum of minterms 1, 4, 6. This is if the sum of minterms are represented with the notation 1, 4, 6 can be represented by M1, M4, M6 minterms. Since these are all the minterms, we expand this minterm as, that is 1 can be written by 0, 0, 1 in the 8421 code, 0, 0, 1. So 0 will be represented by A dash and B dash, 1 is represented by C, 4 will be 1, 0, 0. So A, B dash, C dash, and 6 will be 1, 1, 0. So A, B, C dash. So each product term has all the 3 variables used in the truth table. So it is A, B, C. So this is called as canonical sum of product. So how to convert the standard SOP to canonical SOP? That is, for a function ABC has the sum of product term A dash B plus BC. To convert it into the canonical sum of product, we expand to include all the variables in each product term. That is, say for an example, so in this example A dash B where C is missing, so you write the remaining terms, that is remaining variable in this product C is missing, so you have to multiply it with C and C dash, so C plus C dash. So you multiply the C with C dash, so that you will be getting the product term A dash BC plus A dash BC bar. Similarly, in the second term A is missing, so we are multiplying BC with its with the variable A and its complement, so A plus A dash into BC, so that it is multiplied with ABC plus A dash BC. So by combining all the product terms together and combining combined like terms, that is similar terms, here A dash BC and A dash BC are the same term, so we take only one term, that is A plus A is equal to A. So A dash BC plus the remaining terms A dash BC dash and ABC. So this is the canonical form. See here each product term contains all the input variables, that is A, B, C. Here we don't have all the input variables in each product term. Here C is missing, here A is missing. This is standard form and this is the canonical form. Conversion between canonical forms in the sense we can convert a sum of product. We can represent each Boolean expression with the sum of product as well as product of sum form. If the truth table contains 1 for the minterms M1, M4 and M6, sum of product form can be written by sum of minterms 1, 4, 6. It can be expanded to the Boolean expressions like this, and we are writing the max terms that will be provided by having 0 in the truth table for the input variables, that is 0, 2, 3, 4, 5 and 7, that is and the complement of this one, that is 1, 4, 6. If we have here the output function is 1 for the variables A, B, C. Here the output function is 0 in the same truth table where we have output function is 0 for the input variables A, B, C. That is here 0 is missing, 2, 3 are missing, and 5, 7 are missing. So we are writing the remaining terms in the truth table from 0 to 7. So 0, 2, 3, 5 and 7, we expand this with the Boolean expression. So 0 will be 0, 0, 0. 0 will be represented in original form of variables A, B and C. 2 will be 0, 1, 0. So here in between 1 we have, so 1 can be represented by complement form, 0 will be represented by original form. So when we expand and combine all the sum terms or multiply together, we'll get the conversion between sum of product as well as product of sum form in the canonical forms. So keep it in mind that in the canonical forms, each product term or a sum term must contain all the variables, and we group of sum terms product are ANDed together, and product terms are ORed together in a sum of product.